Hey, Tim's Tips here. A few days before Christmas 2020, here I'm at Boondocker's Welcome location near Lancaster, Pennsylvania, and I'm going to share with you how I insulated my van and why it takes so little heat to heat it. And I do not have any propane appliances or diesel heaters. I got rid of all that and I'll show you how I did it. So here goes. This is the Boondocker's Welcome location near Lancaster, Pennsylvania. As you can see, there's my 50 amp cord going to their service, and it's only drawing 300 watts here pretty much all day. I have the heater running, and because I have a lot of insulation, including this door with 2-inch insulation in it, as you can see here, I can get away with having just one small heater here. So I slept all night like that. A little bit about my background. How did I get here? I'm mainly a systems engineer from Lockheed Martin and other engineering companies, and I look at the data. I always, what's the R value, for example, in a rig, practically, and how can you spread that R value over as many surfaces as possible, including the steel surfaces of the sprinter, which are very difficult to insulate. So what are the requirements? I was a requirements engineer, so I always looked at what do I want? I wanted R19 if possible. That's kind of like the minimum code requirements for most homes in the United States. And I wanted to get that if I could. Decreased thermal breaks. There's a lot of breaks in the Sprinter vans, all kinds of cross beams, members, ribs, studs, stringers, you name it, there's all kinds of metal to insulate around. I wanted it to be lightweight, moisture proof, mold resistant, and no thermal breaks in the floor as well. A lot of van builds have thermal breaks in the floors. So I wanted to do dual layer, 2 layers to accomplish that thermal break capability. So as an engineer, we also look at what aren't we going to do, what don't we want. And so one of the things, they're non-requirements, but necessarily cost was no object. So I had enough money to cover pretty much any insulation I wanted to get. The time investment, I'm retired, so I had almost unlimited hours. And cosmetics were deprioritized. I prioritized performance over cosmetics. So I went on a vendor search. I said, what were good van build insulation materials? I went to U.S. Composites for the pour foam for the floor, Home Depot and this other company similar, A.D. Moyer for insulation, and they delivered it, so that was a good thing. And they had both 1-inch and 2-inch polyiso that I could combine. And those were my main things. They're just the local home supplier. Did I go with polyiso? Low permeability. It was very immune to absorbing water. It had reflective foil face on both sides, good fire performance, and the highest R value of any commonly available insulator on the market. So other factors here that were turned the tide onto polyiso is the foil-faced panels are considered impermeable, and there's got a lot of moisture in a van, so I needed that capability and performance. The EPS is also good, although not quite as good at R value, but it's very non-degradable, so I use that for the door. I did not use extruded polystyrene because it absorbs moisture. It's semi-permeable. So because of this, I use these two. The EPS was the pink stuff, and the polyiso was the foil face stuff. So I also compared it to mineral wool or rock wool, and the R value of mineral wool was 45% less than polyiso and 4.5 times heavier than polyiso insulation. And so I also consider that the wool presents a condensation nuclei for moisture and eventually would get saturated because I had fiberglass in my house, and at times it would retain moisture, actually collect moisture because of its fibrous nature. whereas polyiso is more bubbles of foam, which blocks moisture. Bit of fun here. I'm going to put this on the ceiling of the van. I know it's polyiso with foil backed, foil facing, and I'm going to glue, have some spray glue, some of the high adhesion spray glue, and put these tapestries on the ceiling. It offers both low weight, low cost. You can see the cost over there, around $10 for a tapestry, and glue them up there. So we have just a very lightweight addition to the roof, and for a great insulation job, but lightweight and low overhead as well. So these tapestries are extremely thin. Okay, so I'm going to turn this around a little bit. This is the way I insulated the floor of my van. I saw all these ridges in the van, and I wanted to fill up every one with insulation. And I was either going to do that with strips of insulation or the pour foam insulation, which I'm going to show you right now what I did. I would not recommend this. It was very tedious and difficult. If I were to do it again, I would use the EPS foam, which is actually used for a lot of construction work where you can step on it. It has a very high PSI, pounds per square inch, footfall capability. And I would have put that on the floor, I think, 2 inches of it. But I'm going to show you what I did, just to show you what could be done if one wanted to fill in every nook and cranny with foam. So you can kind of see the floor there of the van, and all the polyiso starting to go up, and the great stuff, expanding foam put in all the nooks and crannies. I knew that if I left nooks and crannies, that moisture would get in and cause problems, so I wanted to insulate everything that I could. So a little more about the aluminum floor in my van. I wanted something very lightweight because I know that sprinters don't have a lot of headroom. So I went to the salvage yard, got the sheet aluminum, and just transported it, cut it out to the exact shape I needed, and elevated it over the floor 2 inches. Had 2-inch spacers there, cut holes. This was very hard to do, cutting all these holes so that I could pour the foam in, and I thought these weights would keep it from buckling up, but buckle up it did, and you can kind of see the results here. The foam is very expanding and hard to hold down. The aluminum would well up, and so eventually ended up having to try to fill up every hole that I got, then try to shave it, shave it out and make it flat. So you can see some success here, starting to fill in all the gaps, and had to pull up all the aluminum once everything's set up and cut it with either a saw or a vibrating saw here. So just go in and trim all this bulging foam. Again, very time consuming, very wasteful of foam, but in the end, got the foam in every nook and cranny as desired. And just when I thought I had everything insulated, all the nooks and crannies, there were more developed. So I had to pour and trim and pour and trim until I got it just right where the aluminum would lay down flat. And now for a commercial intermission. One of the tools I used was a DeWalt large format blade. Is one of those blades you can break off the tips. Only I did not break off the tips. I would use them and then sharpen it, the blade, with a file, just a fine file to keep the edge sharp rather than spending $1 or so on every one of these blades. But it would be sharp enough to cut this polyiso fairly well, and it became an art form. I got very good at carving complex shapes for the polyiso. One of the complex shapes that exists is what I call the door post. It's part of the door mechanism. But this piece of metal sticks out, and I wanted to get 2 inches of insulation on there, at least one. And it was, just complex X, Y, and Z directions. So it took many cuts and measurements to get this right. But in the end, it was done. And, it's a lot of trimming, a lot of trim work and wood that has to be cut to make it look decent. So that will be done. Very labor intensive, but in the end, It has much more insulation properties than most fans. Other difficult pieces were the big sliding door. As you know, that's a complex piece of metal with many struts and ribs and stuff in it, so I insulated inside all the nooks and crannies I could, and then I put a thermal brake in. This is the thermal brake, but part of that rubbed. Once I slid the door back and forth, I saw that some of this rubbed against the door post, as you're sliding it back. So I had to carefully measure the cutout that I needed to make it work, and here it is. Shown here is another thermal brake that I put another inch of insulation on the door and had to cut out, as shown here, several parts that just rubbed against various pieces of the door frame as I was sliding the door back and forth. Another shot of difficult to insulate, the rear door with the window in it. Had to put several layers of insulation along with the window held in as shown there. So difficult to insulate. Floor, wheels, bulkhead, entry step, everything's difficult in this van. But I'm going to show you the bulkhead next in terms of trying to isolate the cockpit driving compartment from the rest of the living quarters. The cockpit never was insulated very well from the factory, so I felt the need to put a bulkhead with a small door in it. But before that, I want to show you the step. So the step area was uninsulated, totally exposed to the elements, and I had to insulate that in the X and Y direction as shown here, and put a piece of sheet metal in there as the new step. And here is the bulkhead, the beginning of the door construction for the bulkhead. I used the EPS, it's very hard. You can step on this, and it's very rigid in that direction. What I did is I took a piece of 1/8 inch wood, plywood, put the EPS board on it, and put the other side on. This is all glued with the Great Stuff expanding foam. I would recommend using maybe Gorilla Glue, the kind that does not expand, or the Great Stuff that does not expand so much as the glue. And then I just let it dry overnight. Meanwhile, constructing the frame just out on the floor, on a flat floor. Stick that up in the van as the bulkhead and tie it down to various points, as many metal points as you can. Insulate it with 2-inch polyiso, and then you have it, the final product with the trim. So that left a lot of areas that were complex shapes that were not insulated at all from the outside. Anything to the right of that black trim, that black rubber strip, was eligible to be insulated because it got extremely cold during cold winter days. So I insulated all of this. And as you can see, I break it up into 3 to 5 different pieces of 2-inch polyiso and glue it down with the Great Stuff foam. And it just was very tedious, cutting the pieces kind of like a jigsaw puzzle and cutting that around the door pieces, the door stay there, because anything that was uninsulated is eventually going to sweat and cause perhaps a rust problem in the future. So here's a photo of the door, the big movable door, how I kind of poked in a lot of insulation. Same with this. I used some of the pink 1/4 inch insulation to, even though it had an R1, kind of help block against the cold and moisture. And I just kind of poked that in where I could to get an extra R value of 1. This shows the windows, some of the detail of the windows, foaming around them, and then as I installed the window, cutting out. Now here's the wheel wells. So this is another project. Cut out the foam with a big knife. Fairly easy to cut. These wedges around it, and then start boxing it in, and then foam around that. I actually poured foam in and used the foam to box in the pour foam. So that was kind of nice that it filled in every nook and cranny there. But again, you had to saw it. Once you were done, it always over foams, and you have to cut it flush. Just use a regular wood saw. So here's the completed box in, and then eventually that was covered with 80/20 80/20 extruded aluminum. But here's a shot sweeping across, and I made all these measurements so that later on I knew where the studs were so I could tie into them. So what are the lessons learned? As far as insulation material, I would definitely use EPS, the pink foam, as opposed to the pouring the foam for the floor, because pouring the foam was very difficult. EPS can be walked on. They use this. They pour concrete on this. Actually, basement floors. They pour tons of concrete on this stuff, and so it's very, very resilient that way. It would have been lighter than the pour foam, which was very dense foam. You could walk on it, but you could have had it lighter using EPS. Probably less costly and much quicker to build. I think the pour foam was about $800 compared. I probably could have done it for 1/4 of that with a pink EPS foam. And also less use of of foam in general on the sides. I have a few like sort of ripples in the side of my van because of using. I really stuffed it with great stuff, and I went a little overboard, so the van does show some ripples. You have to look, you have to know what you're looking for, but I would definitely use less great stuff on the outside sheet metal of the van. That's it for now. Just to recap, pretty much got the R19. It doesn't require a lot to heat this van, so I am not putting in a Chinese diesel heater or any other kind of petroleum fossil fuel heater. It can just be done with either the mini split heat pump or these small little radiators which use 300 watts to keep the van from freezing at night. So thanks for listening, and please subscribe.